So remember that in the previous videos we have discussed the application of calculus. That means the application of differential calculus and the application of integral calculus. Today we are going to discuss about the application of calculus in physics and the application of calculus in business and economics. So first let's discuss the application of calculus in physics, then next to that the application of calculus in business and economics. So calculus in physics, right? Calculus in physics. Before we go to the problems, solving the problems, that means problems application of calculus in physics. So let me recall you some important formulas in physics. So recall these things, right? The first one is the velocity of an object is given by, change in displacement over change in time. That means the rate of change of displacement with respect to time. So which means nothing the derivative of displacement with respect to time where displacement is given as a function of time. Where this displacement is given as a function of what? As a function of time t. So when the displacement is given as a function of time t, then the velocity of the particle is given by change in displacement over change in time, which is the rate of change of displacement with respect to time. So which is nothing the derivative of displacement function with respect to time. So from this we have that the velocity of an object is given by the derivative of this displacement function with respect to what? T. Okay. Now look here. Here we have over 1. So if you take crisscross here, v will be multiplied by dt and ds will be multiplied by 1. So you will get 1 times that ds is equal to what? So that velocity times what? dt. Okay. Now, so 1 times ds is ds. So ds, so which implies ds is given by v times what? dt. Now integrate both sides of this equation. So integrate both sides. Integrating both sides. So take the integral of ds. The integral of ds is equal to the integral of that velocity function, of course, with respect to what? dt. So the integral of ds is equal to the integral of v dt. Now look, remember when we are discussing about that integral part, the integral of dx is x, the integral of dy is y, the integral of dw is w. So the integral of ds is nothing but displacement function s, of course as a function of t, which is equal to the integral of the velocity with respect to. So if you have been given, look, if you have been given velocity as a function of time, then to find the displacement function, you just integrate that velocity function with respect to t. አሁን ሁለት ፎርሙላ አገኝተናል። ለባርጉ don't forget ሁለት ፎርሙላ አገኝተናል። አንደኛው the velocity of an object is given by the derivative of displacement function with respect to t, where this displacement function is given as a function of time. The second formula is that the displacement function, of course as a function of t, is given by the integral of that velocity function with respect to what? dt, when both velocity and displacement functions are given as a function of time. ስለዚህ velocity function ከተሰጣችሁ to find the displacement function as a function of t ከተሰጣችሁ, so to find the velocity you just take the derivative of that displacement function with respect to time, and displacement function ደግሞ ስትፈልጉ velocity function ከተሰጣችሁ you just take the integral of that velocity function with respect to time just to get the displacement as a function of t, provided that velocity is v is in meter per second and this displacement is in meter. So displacement and velocity can be calculated like this. What about the acceleration? Remember this. You know that an acceleration of an object is given by change in velocity over change in time. That means acceleration is nothing. The rate of change of velocity with respect to time. If the velocity is given as a function of time, then this change in velocity over change in time is given by the derivative of this velocity function with respect to t. That means the rate of change of velocity with respect to time, provided that when v is given as a function of what? As a function of what? T. So an acceleration of a moving body is given by the derivative of that velocity function with respect to t. So acceleration is equal to the derivative of velocity function with respect to what? With respect to t. Okay. Now here we have over 1. Take the crisscross. Okay. So what? 1 times dv is equal to a times dt. Acceleration times what? dt. So take integration both sides. So take integration both sides, of course. That means integrate both sides with respect to their variable of integration. So take integration both sides. So the integral of dv is equal to the integral of a dt. So look, what is the integral of dv? As I told you, the integral of dv is v. So the velocity as a function of t is given by the integral of acceleration with respect to t. So velocity is equal to the integral of acceleration function with respect to t, where this a is given as a function of what? As a function of time t. So the velocity is given by the integral of acceleration with respect to t, provided that acceleration is given as a function of time. And finally, work done. Okay, so work done. You know that work done is equal to force times distance when that force is a constant force. When the force is a constant force, when F is constant, you know that work done is equal to force times distance. But when the force is a variable force, that means when the force is given as a function of x, the displacement x, then work done is equal to the definite integral of. That means when the body moves from position A to position B by applying a variable force F, which is given as a function of x, f of x, then when the body moves from A to B, don't forget, by applying a variable force F, which is given as a function of x, then that work done is given by the definite integral from A to B of that variable force f of x, which is with respect to x. So work done is equal to the definite integral from A to B of the variable force function f of x from A to B, of course, with respect to dx, where this f of x is what? A variable force as a function of what? As a function of what? X. So when the body moves from position A to position B by applying a variable force f of x, which is as function of displacement x, then so work done is equal to the definite integral from A to B of f of x t of x, where this f of x is the variable force applied by the given object. አሁን ሰመራይዝ ስናደርገው the important formulas: 1, velocity is given by the derivative of the displacement function with respect to, of course, dt. Okay. Second, and the displacement, of course, as a function of t is given by the integral of that velocity with respect to t. Okay. The third one, you know that acceleration is nothing the derivative of that velocity with respect to t. And the fourth one, if you have been given acceleration as a function of time, and if you have been asked to find that velocity, so velocity is equal to the integral of that acceleration, of course, with respect to t. And finally, the work done by a variable force F, which is given as a function of x, is, so work done is equal to the definite integral from a to b of that variable force f of x with respect to, of course, x. So as in the formula, which of course you have just discussed them in physics. Physics ላይ ተምራችኋል። አሁን ምንድነው ፊዚክስ ላይ ቬሎሲቲ ማለት changing displacement over changing time ተምራችኋል። or displacement ማለት velocity times time ተምራችኋል። and acceleration is nothing change in velocity with respect to time, or velocity means acceleration time ተምራችኋል. or work done is equal to force times distance, but when that force is given as a function of x, then that work done will be the definite integral from a to b of f of x dx. So now let's do examples, of course, from your textbook. So let's do examples. Okay, the first example is that the acceleration of a particle is 3t, where t is in seconds. So the solution is, look, so the acceleration of a particle is given as a function of t. Our acceleration as a function of t sectoral, which is 3t. So acceleration a of t is given by what? 3t, where t is, of course, in second. So acceleration as a function of time, okay. And after leaving the point O, there is an initial point O. If the velocity at the starting point O is 1, that means the initial velocity is given. When the time was 0, when t was 0, then the initial velocity was, which is 1 meter per second. So automatically you can get the initial displacement. So the initial displacement was, that is velocity times t, which is 1 times 0 is, which is 0. So initial conditions have been given. The initial velocity is 1, the initial displacement is 0. That means, v of, when the velocity is given as a function of time, v of 0 is 1, and when the displacement is given as a function of time, so s of 0 is 0. When the value of t is 0, so v of 0 is 1 and s of 0 is 0. These are what you call, they are initial conditions. They are the initial or the starting conditions. They understand? So let's go to the problem. Then find the velocity and displacement after t. That means you have been asked to find the velocity as a function of time and the displacement as a function of time. So from the previous discussion, you know that, so the required, what is required? What's required? V of t and displacement as a function of t. Okay. So we know that velocity as a function of t is given by what? Formula. Velocity is nothing the integral of acceleration function with respect to t. Okay. So velocity is nothing the integral of acceleration function a of t with respect to t, of course. So this is the integral of what is the acceleration function, which is 3t, of course, with respect to what? dt. So the velocity function is given by the integral of 3t is what? 3t squared over 2 plus what? 0. So the velocity, look, so the velocity as a function of t is given by 3 over 2 squared plus what? c. On here c, the constant of integration c, by using the initial conditions ማግኘት መቻል አለብን። ምክንያቱም at a particular time t velocity ስለምንጠየቅ የሲ ዋጋ ማግኘት መቻል አለብን ማለት ነው። So by the initial condition, you know that v of 0 is what? 1. So from the initial condition, conditions, we have that, what do we have? We have that, what? So v of 0 is equal to what? 1. So አሁን በቬሎሲቲ ፈንክሽናችን ውስጥ በቲ ቦታ ማን እናስገባለን? 0 እናስገባና የዋጋ እንፈልጋለን፣ የሲ ዋጋ እንፈልጋለን። So that will be 3 over 2. አሁን t ነበር እዚህ ጋር t ስኩዌር ነው አይደል? So በቲ ቦታ ምን እናስገባለን? v of 0, which is 0 እናስገባለን። 3 over 2 times 0 squared plus is equal to 1. So 3 over times 0 is 0. እዚህ ጋር ምን ይቀራል? c is equal to 1. So constant of integration የሲ ዋጋ አገኘን, which is 1 ማለት ነው። Therefore, so the velocity function v of t is given by what? Velocity function ማን ነው ማለት ነው? 3 over 2, of course. 3 over 2 squared 3 over 2 squared plus what 1 ነው ማለት አሁን ልባሩ ስለዚህ what is the velocity after 3 seconds what is the velocity of the particle after 5 seconds what is the velocity of the particle after 10 seconds after 20 seconds after 40 seconds እያለ ሊጠይቅ ስለሚችል ሶ በቲ ቦታ 10 ሰከንድ 20 ሰከንድ 30 ሰከንድ እያስገባችሁ አዳት ፓርቲኩላር ታይም የማዋጋ ማግኘት ትችላላችሁ የፓርቲክሉን velocity ማግኘት ትችላላችሁ ማለት So velocity as a function of t is given by 3 over 2t squared plus 1. Okay. Next. So let's find displacement as a function of time. So now let's find the displacement function. You know that displacement is nothing. The integral of velocity with respect to what? Time. So the displacement function s of t is given by the integral of what? Velocity as a function of t or v of t with respect to, of course, t. So that will be the integral of 3 over 2t squared plus 1 with respect to what? dt. Okay? So that will be is the integral of 3 over 2 squared is what? 3 over 2 times the integral of t squared is what? Cubed over 3. How normally do you integrate the integral of x squared, the integral of y squared, so the integral of t squared is t cubed over 3. Of course, plus what's the integral of 1, which is t, then finally plus what? C. So this is the displacement function. So the displacement that will be so 1 over 2t cubed plus t plus c. This is the displacement function. So let's see. Displacement function is given by 1 over 2t cubed plus t plus c. So we should find this constant of integration by using the initial condition. What are the initial condition? You know that initial displacement, that means s of 0 is given by 0. So from that we can find this constant of integration. So s of 0 ማለት 0 ስለሆነ which implies አሁን በቲ ቦታ ምን ታስገባላችሁ 0 ታስገባላችሁ በቲ ቦታ 0 ሲገባ ምን ይሆናል 1 over 2 times 0 cubed plus 0 plus of course c which is equal to 0. So automatically these things are 0. So c is equal to what 0. Therefore, the displacement function is given by what? 1 over 2t cubed plus t. This is the displacement function. Where t is in second. So let's say, what is the displacement of the particle after 10 seconds, after 5 seconds, after 20 seconds, after 50 seconds? Which one of the following is correct? Which one of the following is correct? A. The velocity function is this. B. The displacement function is this. C. The displacement after 10 seconds is this. D. The velocity after 20 seconds is blue. በምርጫ ሊጠይቅ ይችላል ኢንትራንስ ኤግዛሚኔሽን አለ right ወርክአውት ከሆነ ያው እንደ የወርክአውቱ ABC እያሉ ሊጠይቁ ስለሚችሉ so the displacement say after 10 seconds after 20 seconds after 30 seconds እነዚህ በሙሉ በዚህ በቲ ቦታ እያስገባችሁ ምንን ማግኘት ትችላላችሁ the displacement of the particle ማግኘት ትችላላችሁ so let's do the next problem it says that the displacement of a particle at time t is given by s of t is equal to t to the power of 4 plus 3t squared. Okay, so look, the solution, the displacement function as a function of t is given by t to the power of 4 plus 3t squared. Okay, so find its velocity and acceleration at the end of course 2 hours. At the end of 2 hours የሚጠይቀው particular አድርጎታል ማለት ነው ምርጫ ላይ ስለሆነ ግን ይፈልገውን መጠየቅ ይችላል okay where s is in kilometer displacement is in kilometer and t is in hours anyway so now look what is required is a velocity at 2 hour and acceleration at 2 hour so the velocity of the object of the particle at the end of 2 hours and the acceleration of the particle at the end of 2 hours. Okay, so first let's find the velocity function and the acceleration function. Now displacement as a function of t ስለሆነ የተሰጠን variable displacement ስለሆነ የተሰጠን so we should find that variable velocity and the variable what? Acceleration. So you know that the velocity is given by what? So you know that velocity is given by what? The derivative of displacement with respect to t. So velocity is nothing ተነጋገርነው ፎርሙላ መሰረት velocity is nothing the rate of change of displacement with respect to time ነው ብለናል velocity ማለት the rate of change of displacement with respect, that means the derivative of displacement function with respect to t ማለት. So the derivative of this ማለት t is the power of 4 plus 3t squared. You just take the derivative of that one. So derivative of t to the power of 4 is 4t cubed plus derivative of 3t squared is 3 times 2 times what? T ማለት. So that will be 4t cubed plus 3 times 2 is 60. This is the velocity function. So the velocity of the particle after time t is given by 4t cubed plus 6t. አሁን ልባሩ የጠየቀው ምንድነው እዚህ ጋር? What is the velocity at the end of 2 hours ነው ያለው አይደል? So አሁን ያችን ሁለት 2 hours እዚህ ውስጥ እያስገባን so v of 2 is equal to what? Velocity at the end of 2 hours. Velocity at the end of 2 hours. V of t is equal to 4 times 2 cubed plus 6 times 2. So 2 cubed is 8. 8 times 4 is 32 plus 12 is what? So 44 kilometers per hour. 44 kilometers. So the velocity of the object, the particle, at the end of 2 hours is given by 44 kilometers per hour. And the next is what is the acceleration after t time? So you know that acceleration is given by nothing changing velocity over changing time. That means the rate of change on velocity with respect to what? T, which is the derivative of velocity, so which is dv, the derivative of velocity function with respect to t. So which is the derivative, wait, what is the velocity function? Which is 4t cubed plus 6t, then its derivative will be the acceleration function. The derivative of 4t cubed is 4 times the derivative of t cubed is what? 3t squared. Plus the derivative of 6 is 6. The derivative of t is 1, so which is 6 mal. So acceleration function is given by what? 4 times 3 is 12t squared plus 6. So the acceleration is nothing the rate of change of velocity with respect to time. So which is the derivative of the velocity function, where velocity is given as a function of time, of course, which is 4t cubed plus 60. So the derivative of this one is 4 times 3t squared plus 6. So which is, so what is the acceleration after at the end of 2 hours? So a of 2 is given by what? What is the acceleration at the end of 2 hours? So a of 2 is given by what? 12 times 2 squared plus 6. So which is, this is 4 times 2 is 48. 48 plus 6 is 54, I think, which is 54. So which is kilometer per hour squared, of course. So the acceleration after 2 hours is given by 54. Hey, calculation, arithmetic part check out. ስናባዛ ስንደምር ምናልባት ደሪቬት ስናረግም ስናባዛ ከተሳሳትን just check this minor mistakes. So the velocity as a function of t is obtained by taking the derivative of the displacement function, and we have also calculated the velocity at the end of 2 hours, and we have got the acceleration function by taking the derivative of the velocity function, because the velocity function is given as a function of t v of t. Then finally we have calculated the acceleration at the end of 2 hours. So the next problem is about work done. Find the work done when a particle is moved from position A or x1. You can see also from x1 or A is equal to 1 to x2 or B is equal to 4 along a smooth horizontal surface by a variable force of what? F of x is equal to x squared minus 1, of course in Newton. The force is in Newton. So what is given? What is given is that variable force is given as a function of x, where what? X squared minus 1. So what's required? Required is the work done, of course. What is the work done? You know that work done is nothing force times distance, provided that the force is a constant force. But now the force is a variable force. So wait, the work done. So the work done by a variable force moving the object from A to B or from x1 to x2 is given by the definite integral from A to B of that variable force f of x with respect to x. This is a formula. In formula, work done by a variable force f of x is given by the definite integral of that function the force function, of course, when the object moves from position A to position B. So that will be the definite integral of our work done. Our force is x squared minus 1, of course, which is dx from A is 1 to 4. So that will be the integral of x squared is what? This is x the power of course 3 over 3 minus the integral of 1. That means the integral of dx is what? X. So from where to where? Evaluated from 1 up to what? 4. So that will be first insert 4 here. አራት መጀመሪያ እዚህ ጋር እናስገባለን. 4 cubed over 3 minus 4 of course. Then minus, then 1 ታስገባላችሁ. 1 cubed, which is 1 over 3 of course, minus 1. So which is 4 over 3 is I think 64 over 3 minus 4. Then this is 1 over 3 minus 1 is negative 2 over 3. Negative times negative is positive 2 over 3. Here 3 is common. 3 divided by 3 is 1. 64 minus 3 is common. 3 divided by 1 is 3. 3 times 4. So 64 minus 12 is what? 64 minus 12 is what? So 52. So this is 52 over 3 plus 2 over 3 of course. So which is 52 plus 2 is what? So which is 54 over 3, which is I think 80 joule. So the work done by the variable force given by f of x is equal to x squared minus 1, where the force is in Newton of course, is can be calculated by the definite integral from 1 up to 4 of the given variable force x squared minus 1 dx. Then finally you can get that 18 joule. Okay, check out what's ስንደምር ስንቀንስ ልንሳሳት ስለምንችል. So this is the work done. ስለዚህ እነዚህ ፎርሙላዎች አሁን መጽሐፋችሁ ላይ ጥያቄዎች አሉ፣ እኔ ያልሰራኋቸውም ጥያቄዎች አሉ። ልክ በዚህ መሰረት ስሯቸው። Don't forget these formulas ማለት. So velocity ማለት the derivative of displacement with respect to t, okay? And displacement ማለት the integral of velocity with respect to t. Acceleration ማለት the derivative of velocity with respect to t. And velocity ማለት the integral of acceleration with respect to t. And finally, work done. The work done by a variable force f given as function of x of course is the definite integral from a to b of that f of x dx. እነዚህ ፎርሙላዎች ተጠቅማችሁ ጻፋችሁ ላይ application of calculus in physics የሚሉ review exerciseም ላይ ያሉ ፕሮብሌሞችም ላይ ያሉ እኔ ሰርተወሰኑት ነው የሰራሁት። ያልሰራኋቸውን ደግሞ ሞክሯቸው። ሪቪው ፕሮብሌም ላይ ደግሞ እንሰራለን።